So in the previous video, we looked at what a relation is. A relation is connecting two elements from a set. Now we're going to look at some specific properties of relations. So a relation can be reflexive, or we look at reflexivity. So a relation is reflexive if for all A element of that set, because remember a relation is defined on a set, if A is true for all A in the set. So let's start with a very small example. If my set B is the elements just 1, 2, and 3, in my relation R is defined on B, and it's defined by ARB. So if I take two elements, A and B, out of the set B, that is true if and only if, let's say, A plus B is less than 10. All right. Now if we look at those elements, very quick to check. 1 plus 1 is less than 10, 2 plus 2 is less than 10, 3 plus 3 is less than 10, 3 plus 1 is less than 10. This is going to work for all of them. But now we're looking at reflexivity. So we want to see, is ARA true? That's what we're looking at. So we can sort of look at it and test it on each one. So we want to know, is 1R1 true? Yes, because 1 plus 1 is less than 10. Is 2R2 true? Yes, because 2 plus 2 is less than 10. Is 3R3 true? Yes, because 3 plus 3 is less than 10. So R is reflexive here. But it's not always that easy. Our sets are going to get much bigger. So by just testing each one at a time is not an effective way, because we will be looking at much bigger sets and then we're going to get in trouble. So let's see, how do we check if a set is reflexive or not? What strategies can we use? All right, here's two examples. The first one, my relation R is defined on a set A. A is 1, 2, 3, 4, 5, 6, 7. A or B if and only if A is equal to B. Now this one is very, very simple. Now we know, if I look at that set, 1 or whatever B is true only if the A and the B are the same. So what this means is 1R1 is true, 2R2 is true, 3R3 is true, because that's how it's defined. So this one is actually, in its simplicity, true. So if we look at ARA, that's always going to be true, since A is equal to A. R is reflexive. All right, so the next one's going to take a little bit more work. Let's look at this one. 1, 2, 3, 4, 5 is my set A, and I define P on A by APB if and only if A plus B is less than 6. All right, so now we've looked at what the elements of this relation are, for which elements it works. Now my question is, will APA be true? Well, this is what we're looking at. So what we want to see is, will A plus A be less than 6 for all the A's? Doesn't matter which A, not just for one, for all of those elements of that set. Well, 1 plus 1 it works for, 2 plus 2 it works for, 3 plus 3, whoops, I'm trouble already. 4 plus 4 I'm in trouble, 5 plus 5 I'm in trouble. So to show, so we can see that P is not reflexive. But to show that, I don't have to look at a general case. To show that it's not reflexive, I need only one that doesn't work. So if I look at 3P3, that is not true, since 3 plus 3 is equal to 6, and that is not less than 6. So we need one counterexample to show that it doesn't work. So now I've shown that P is not reflexive. Now in this section of relations, we're going to see a lot of divisibility. So I just want to remind you of what divisibility means. If A is divisible by B, we sometimes write it like this. B is a divisor of A. If I can find an element of Z, an integer k, such that A is equal to B times k. All right, so we know 3 is a divisor of 21. Why? Because I can find a number k so that 21 is equal to 3 times k, and that k is 7. So if I can find something to multiply with this B to get A, then it's divisible. So let's look at this next example. Define P on Z. So now I'm working on the whole set Z. So I already know I can't test each and every element. I've got to look at something general. APB, if and only if A minus B is divisible by 3. So this relation holds between two numbers if the first one minus the second one is divisible by 3. All right, so what I'm looking at reflexivity. So I'm looking at APA. All right, so how do I look at that? So if I look at APA in general, so it's not a specific A, not a specific number, I have to look at it in general. So those two numbers have to be the same. All right, so that's what I'm looking at. So APA is true, or is it false? Now we need to figure out, get some ideas, like before, because if it's true, I have to show it in general. If it's false, I need one counterexample. But what happens if I've got a number minus itself? A number minus itself gives me 0. Is 0 divisible by 3? Well, from our definition, I must find a number to multiply by 3 to get to 0. Any integer, I've got it. So a minus a is equal to 0. That's the same as 3 times 0. So a minus a is divisible by 3 because 0 is an integer. So it works for the definition of divisibility. So a minus a is divisible by 3, therefore APA is true. So therefore P is reflexive. And now we've tested it for reflexivity. If you're a little bit confused about this example, it's because it's going to come up a lot. We've shown that it's reflexive, but let's just look at some elements in this set P, some combinations of A and B that will work. A minus B must be divisible by 3. So numbers that are divisible by 3, the number 3 is divisible by 3. So if this one minus this one gives me the number 3, then APB is true. So 6P3 is true, 10P7 is true, and there is an infinite number of those that are true that gives me the number 3 if I subtract them. What if I get the number 6 if I subtract them? 6P0 is true. 10P4 is true, and I'm not even, this is on Z, so I'm not even looking at negative numbers yet. So as long as the first number minus the second number is divisible by 3, then APB is true. But I've been looking at reflexivity, so I've shown that it's reflexive. Now when we look at these properties of relations, there are 3 big properties that we have to look at. The first one we've looked at now is reflexivity, to see if it's reflexive. The next video we're going to look at to see if it's symmetric, and we have to look at transitivity. So those are the 3: reflexive, symmetric, transitive. Those 3, we need all of them, and we need to be able to look at all of them.